So 3, 1, first row. 3, 1, there is no S1, 0. There is no S2, 0. A1. A1 coefficient 1. Next, A2, 0. Next, 4, 3, S1 is there, minus 1. There is no S in second equation here. There is no S2, 0. And A is there, 1. Next, last is 1, 2, 0. S2 is there. S2 is nothing but coefficient 0, 0. So, and so here, so the patient's matrix, the next x1, x2, 1, S2, A1, A. So this is the X matrix. So next 3, 6. So this is matrix form. Given the objective, so in objective function, maximum of z equals to here. So the given object function minimization. To convert minimization to maximization. So to multiply both sides by negative, that is minus 3x minus x after multiplication. So this is the objective function.
సార్ పీడిఎఫ్
So
నాట్
minus
విజిబుల్
2x1
సార్
minus x1.
డిస్ప్లే వస్తుంది వేరే ప్రొఫైల్
రావట్లేదా? This is objective function. So in objective function, S1 and S2 coefficients are zeros. So 0 S1 plus 0 S2. And here in artificial variables, so we can add coefficients to minus m, minus m A1, minus m A2. So these are the important. So in objective function, so minus m1 A1, minus m A2. So remaining coefficients are zeros. And minus x1, minus x2. So this is maximum of z dash is equals to minus 2x1 minus x2 plus 0 s1 plus 0 s2. So s1, s2 coefficients are zeros. But in artificial variable coefficients must be minus m. Artificial variable coefficients minus m. So minus m a1 minus m a2. So this is the objective function. Here basic variables. So basic variables are three variables. So in this equation, basic variables are A1. First equation, basic variable is artificial variable. So next, second equation also artificial variable A2. In third equation is basic variable is S2. So these are the basic variables A1, A2, S2. So first equation A1, second equation A2, third equation S2. In second equation S1 also there. So we cannot consider please wait for 5 minutes. I will be back. So these are the artificial variables A1, A2, S2. So simplex table. In simplex table, so first one basic variables. So basic variables are artificial variables A1, A2, and S2. So these are the basic variable in equation 1, 2, 3. So next CB, coefficients in basic variables in objective function. The coefficients, so these are the coefficients in objective function. Basic variable coefficients minus m, A1, A2. So next S2 0, S2 0. So CB is equals to minus M1 minus M0. The coefficients in objective function. So next XB is equals to these values. XB is equals to 3, 6, 3. So this is XB. So next X1, X2. So given variables X1, X2 and S1, S2. Adding variables S1, S2 and A1, A2, artificial variables. So same, copy on here this matrix. So 3, 1, 0, 0, 1, 0, first column, first row. Second, 4, 3, minus 1, 0, 0, 1, second row. So third row also. So this is a matrix. So next, Cj. Cj is equals to coefficients of objective function. Coefficients of objective function. Minus 2, minus 1, 0, 0, minus m, minus m. So these are the objective function x1, x2, s1, s2, a1, a2. So these are the x1 coefficient, x2 coefficient, s1, s2, a1, a2. Coefficients in objective function. So next, so we have to find out delta J. So delta J formula. So delta J is equals to CB into XJ minus CJ. So this is the formula for delta J. So we have to find out delta J for each and every column. So CB delta J is equals to CB minus XJ minus CJ. CB XJ, X1, X2. Next, S1, S2, A1, A2 minus Cj. Is clear? So this is the formula for delta J. First one. So this is. So multiply CB into XB. So this is CB. So this is X. XJ is nothing but X1. So minus 3, minus M into 3. So like this, minus 3, minus 3m, minus 4m. So minus 3m minus 4m, minus 7m plus. So this is 0. 0 into 1, 0. So total minus 7m. So minus 7m minus of minus 2, Cj, C1. So minus 2. So that is minus 7m plus 2. Xi coefficient minus 7m plus 2. So this is the first one, first delta J. So once again, so this is CB. So this is X1. So formula CB into XJ minus CJ. CB into XJ minus CJ. CB into XJ minus CJ. So this is the formula. C into X1. CB into X1. M minus M 3. Minus 3M minus 4M. So total minus 7M plus 0. 0 into 1, 0. So minus 7M. So minus of minus 2 plus 2. So minus 7M plus 2. So first one, delta 1. So next, same. CB into second one, X2. CB into X2. So minus M into 1 minus M. Minus M. So next, minus 3M. Minus 3M plus 0. Is clear? Multiply adding each and every term. Minus M, first one. Minus 3M, second one. Plus 0 into 2, 0. So therefore, minus 4M minus of minus 1 plus 1. So formula CB into XJ minus CJ. So total minus 4M plus 1. So next, S1. CB into next variable, S1. Multiply 0, first one. Second one, minus M minus 1 plus M. Remaining 0, here also CJ also 0. So total plus M only, plus M. Next, second one, S2. Second variable. So multiply 0, minus M into 0, 0. Second one, minus M into 0, 0. 1 into 0 plus 0, minus 0. So total 0. So that is 0. Next, artificial variables. A1, same. Minus M plus 0 plus 0. So total minus M. So this is minus of minus M plus M. So plus M minus M total 0. So next, A2. Here also 0 minus M 0 and minus of minus M plus M 0. So these are all our delta J's for each and every column. X1, X2, S1, S2, A1, A2. So these are the delta J's. So in this delta J's, so we can choose most negative delta J. So these all are positive up to S1 positive, S2 positive, A1, A2, all are positive. So but here minus 7M plus 2, minus 4M plus 2, 4M plus 1. So these are the negative values. So we can choose incoming vector in these two values. So most negative value. So minus 7, for example, M is equals to 1, minus 7 plus 2. So that is minus 5. Next here minus 3, M is equals to 1. For example, here M is equals to 1, here minus 5, here minus 3. In these two values, so which is the least number? So most negative number is nothing but minus 5 is the most negative number or least number. So we can choose. So this is the incoming vector. So X1 is incoming vector. X1 is incoming vector. So we can identify outgoing vector. How to identify outgoing vector? Minimum ratio. Minimum ratio formula xb by x1. So which is the incoming vector? Here x1 is incoming vector. So divided by xp by incoming vector. So xb by x1. So here minimum ratio. So minimum ratio 3 divided by 3, 1. So next 6 divided by 4, 3 by 2. Next 3 divided by 1. So 3. So in these three values, 1, 3 by 2, 3. So minimum value is first one. So that is 1. So this is outgoing vector. Incoming vector is x1. Outgoing vector is a1. Artificial variable. Is clear? So this is the incoming vector. So this is the outgoing vector. So intersection of incoming and outgoing vector is called key element. Key element. So to make key element as 1. To make key element as 1. So by using row operations only. So here a1. So this is incoming vector. So this is outgoing vector. x1 is replaced by, so a1 is replaced by x1. In basic variables, a1 is replaced by x1. A1 is replaced by x1. So that's why in x1 terms, we can convert 0, 1, 0, 0. In x1 terms, we can convert 1, 0, 0. x1, 1, 0, 0. So by using row operations only. So we can take the matrix. So this is the matrix. Up to here, this is the matrix. So first row, R1 tends to R1 divided by 3. So this is 1. Total 1. 1, 1, 1 by 3, 0, 1 by 3, 0. So here, 1, 1, 1 by 3, 0, 0, 0. So we can eliminate this one. A1, artificial variable. We can eliminate artificial variable. So that is A1. No need to write A1 in next table. So here, basic variables. Basic variables are A1 is replaced by X1. So that is X1. Next, A2, S2. Same. So but here, Cj values -2, -1, 0, 0, minus m. So no need to write a1. Artificial variable is already eliminated. So here coefficients of x1 coefficient is -2 in objective function. Next, minus m, 0. So next here, in this matrix, so we can do row operations. So x1 is converted to 1, 0, 0. So that's why R1 row, first row is divided by 3. 1, 1, 1 by 3, 0, 0, 0. Next, R2 tends to R2 minus 4 into R1. So here 1 is there. So second row, 4 is there. So first row is multiplied by 4 and subtraction of second row. R2 minus 4 into R1. So we are getting here 0. So next, here also R3. R3 1 is there. Here also 1 is there. So 1 minus 1, 0. So next row operation, R3 tends to R3 minus R1. So we are getting here zeros. So 1, 0, 0 on x1 column, because a1 is 1, 0, 0. A1 is replaced by x1. So that's why we are converting a1 x1 terms as 1, 0, 0 by using row operations only. Is clear? After doing row operations, so this is the matrix. We are getting this matrix 1, 2, 2, 1, 0, 0, 1 by 3, 2 by 3, 5 by 3, 0, 0, 0, minus 1, 0, 0, 1, 0. So these are the, this is the matrix after getting row, after doing row operations. So next we have to find out delta j's. So delta j's. So cb xj minus cj. So this is the formula for delta j. So multiply cb into x1, 0, 0, first one, plus 2, minus 2, 0, 0, plus 2, minus 2 plus 2, 0. Next, second one, Second one, minus 2 by 3 minus 5m by 3 plus 0 plus 1. So after simplification, minus 5m plus 1 by 3. So this is the delta 2. Next, S1 multiply 0 plus m 0 0 plus m. So next here multiply 0 0 0 0 total 0. So next here 0 here also. First one 0 minus m 0 plus m minus m plus m 0. So total this is 0, this positive plus m 0 0. Here only one negative is there. So only one negative, that is minus 5m plus 1 by 3. So this is the negative value. There is no second, there is no multiple negative values, only single value is there. So negative value. So this is the incoming vector. So this is incoming vector. So next, so we can choose outgoing vector. So outgoing vector. So outgoing vector. How to choose outgoing vector? Minimum ratio. Minimum ratio is xb by x by 5. Here 2 divided by 5 by 3, 6 by 5. Here also. So 2 divided by 5 by 3, 6 by 3, 6 by 6. So here minimum ratio. So first one is highest value 3. Remaining 6 by 5, 6 by 5. So that is 1 point something. In these two values, we have to choose one value, that is must to be artificial variable. So we can eliminate artificial variable. That's why we are taking the second one. So this is eliminated. Artificial variable 6 by 5. Here tie is there 6 by 5, 6 by 5. But we can eliminate artificial variable in big game method. So that's why we are eliminating R2. R2 is nothing but, so this is the incoming vector x2. So this is the outgoing vector. Intersection of incoming and outgoing vector is 5 by 3. So that is key element. In next step, R2 is multiplied by 3 by 5 to make this element as 1. That is, so this is the A2. A2 is replaced by x2. A2 is replaced by x2. So that's why we are converting x2 as 0, 1, 0. 0, 1, 0 in a matrix. So by using row operations, to make this element as 1, R2 into 3 by 5. Opposite, 3 by 5, we are getting 1. So next row operations, here 1. Next row operations, R1 tends to R1 minus 1 by 3. R2, second row is multiplied by 1 by 3 minus first row. So here 0. Here also, second row is multiplied by 5 by 3. R3 minus 5 by 3 R2. Here also 0. Is clear? After row operations. And now eliminate A2, artificial variable also. Eliminate artificial variable, remaining matrix. So this is the remaining matrix, x1, x2, s1, s2. So this is the remaining matrix. Basic variables x1, x2, s3. Here A2 is replaced by incoming vector x2. So this one. So in basic variable x1, in place of A2, x2, s2, and the coefficients. X1 coefficient is minus 2. X2 coefficient is minus 1. CB minus 1. So here. So minus 2, minus 1, S1 coefficient, S2 coefficient 0. So this is the after doing row operations, we are getting this matrix. 3 by 5, 6 by 5, 0, 1, 0, 0, 1, 0, 0. Next 1 by 5, 0, minus 3 by 5, 0, 1, 1. So this is the matrix. So next we have to find out delta J. Delta J values. Here CB into x1. 0, minus 2, 0, 0, minus 2 into plus 2, 0. Here also. Second one, x2. 0, minus 1, 0. Minus 1 into plus 1, 0. Next, CB into x1. So minus 2 by 5, minus plus 3 by 5, plus 0. So 1 by 5. 3 by 5, 2 by 5 is 1 by 5. So that is 1 by 5. Next. So next S2. 0, minus 2 into 0, 0, plus minus 1 into 0, 0, plus 0 into 0, total 0. So here all delta j's are greater than or is equals to 0. So therefore the above table is optimum. The optimal solution of given simplex table is x1 is equals to x1 3 by 5, x1 value 3 by 5, x2 value 6 by 5. So this is the solution of given LPP. x1 3 by 5, x2 6 by 5. So substitute x1, x2 values in given function. So that is maximum of z is equals to minus 12 by 5. So x1 is equals to 3 by 5, x2 is equals to 6 by 5. So minimum of z is equals to multiply minus on both sides. So we are getting minimum of z is equals to 12 by 5. So this is the solution. So this is the required solution. Is clear? First we have to eliminate artificial variable in simplex table A1, A2. After continue the process, all delta j's are greater than or is equals to 0. First, we have to eliminate artificial variables in simplex table and continue the process up to all delta j's are greater than or is equals to 0. Then the table is optimal. So therefore, the x1 and x2 values, we are getting the required solution. So next, another example. Solve the following LPP by big M method. So maximum is given maximum of z is equals to 5x1 plus 6x2 subject to constants. x1 plus x2 is equals to 5 and x1 greater than or is equals to 2, x2 less than or is equals to 4 and x1 comma x2 is greater than or is equals to 0. For big M method. So given objective function is already maximum. No need to convert or no need to multiply, minus is already given in maximization. Next, here is equals to z is equals to case and greater than or is equals to case. In these two cases, we can add artificial variables. Is clear? When the inequality is equals to comma greater than or is equals to. In this case, we can add artificial variable to the constants and less than or is equals to case. In this case, no need to add artificial variable. No need to add artificial variables. First two cases, we can add artificial variable A1, A2. If less than or is equals to case, no need to add artificial variable. Just we can add slack surplus variables. Is clear? So first equation is equals to is there. So we can add artificial variable A1, x1 plus x2 plus A1, one artificial variable is equals to 5. Next, second equation, greater than or is equals to z, greater than or is equals to is there. First to convert greater than or is equals to 2. First to convert greater than or is equals to equals to equality. First to convert greater than or is equals to equality. Next, equality to we can add artificial variable. So that is minus S1 subtraction. X1 minus S1 plus A2 plus A2 is equals to 2. So this is greater than or is equals to case. So first the second equation, x1 minus s1 is equals to 2. To make greater than or is equals to 2 equality. So that is x1 minus s1 is equals to 2. Subtraction of some variable that is s1. Next is equals to case is there. Is equals to case, we can add some artificial variable that is a2. x1 minus s1 plus a2 is equals to 2. Next, another equation is there, x2 less than or is equals to 4. Is not given. X2 less than or is equals to 4. So here x2 plus s2 is equals to 4. Another equation is clear, is not given. X2 plus artificial some variable s2 is equals to 4. This is the third equation. Write down x2 plus s2 is equals to 4 on here standard form. After x1 comma x2 s1 s2 a1 a2 all constants are greater than or is equals to 0. All variables are greater than or is equals to 0. Here is not given one more equation, so that is x2 plus s2 is equals to 4. Here another equation is missing, s2 plus x2 is equals to 4. So this is the third equation. So all variables x1 x2 s1 s2 a1 a2 greater than or is equals to 0. Next, matrix form. Matrix form 1 1 first row 1 1. Next s1 s2, there is no s1 s2 0 0 a1 1 a2 0. So that is 1 1 s1 s2 0 0 a1 1 a2 0. Next second row. So here x1 is there 1 x2 0 s1 minus 1 s2 0 a1 0 a2 1. So this is here 1 0 minus 1 0 0 and 1 is there a2. So this is second row. Next last row. So last row x2 plus s2 is equals to 4. So this is x1 0 x2 1. There is no s1 0 s2 is equals to 1 coefficient a1 0 a2 0. So this is the matrix form into x1 x2 s1 s2 is equals to 5 2 4 matrix form. Next simplex table, table 1 simplex table. So basic variables, so basic variables are artificial variables are always basic variables a1 a2. So these two are basic variables. So next in third equation there is no artificial variable s2 plus x2 plus s2 is equals to 4. There is no artificial variable, so we are taking basic variable as s2. a1 a2 s2 are the basic variables. a1 a2 coefficients are minus m minus m. Next, s2 coefficient is 0 in objective function. Next, 5 2 4. So these are, so 5 2 another 4 is there, another equation. So 5 2 4. So these are xb values in table. 5, 2, 4. Next, x1, x2, s1, s2, a1, a2. So this is the variables. So next, matrix. So this is matrix up to here. First equation coefficients, second equation coefficients, third equation coefficients. So these are the three rows. Next, we have to find out delta j's. Delta j's, delta j is equals to cb xj minus cj formula. cb into xj minus cj. So this is the delta j formula. First one, cb into x1. So minus m and again minus m. So minus 2m plus 0 and minus 5. So minus 2m minus 5. First one. Next, second one. Minus m 0. Minus 1 into m minus m into 0. 0. Here also 0. So therefore minus m again minus 6. So minus m into minus 6. Next, third one. S1. Minus m into 0. 0 plus m. 0. So here plus m. Mistake. Printing mistake is there. Plus m. So minus m into minus 1 plus m 0 minus 0. So total 0. So next second one S2 0 0 0 0. All are zeros. A1 also 0. Minus m plus m. Minus m plus m 0. So next A2 also 0. A2 also 0. Minus m plus m. All are zeros. So but here in printing mistake. So this is plus m. Plus m. So in these two negative values, so these are the two negative values, minus negative, minus m, minus 2m, minus m. So in these two negative values, so we can choose most negative value. For example, m is equals to 1. M is equals to 1. First number is minus 7. Second number is minus 6. For m is equals to 1, minus 7. Here also minus 7. So we can choose most negative. Here we are getting same values. So m coefficients here minus 1 minus 2 is there, so we can choose minus 2m minus 5. So this is the most negative value, minus m minus 2m minus 5. So this is incoming vector. So this is incoming vector. We can choose outgoing vector as xp, minimum ratio, xp by xj. So that is xp by x1. So 5 by 1 5, 2 by 1 2. Next 4 by 0 0, undefined. 5 by 1 5, 2 by 1 2, undefined. So minimum ratio is second one. So that is A2. Eliminating A2, second artificial variable. So that is, so this is incoming vector. So this is outgoing vector. Intersection of incoming and outgoing vector is minimum key element. So this is key element. A2 is eliminating. So this is A2. A2 is outgoing vector. X1 is incoming vector. So A2 is X1 is replaced by A2. X1 is replaced by A2 is nothing but in X1 is converted to 0 1 0 is already 1 is there. Here 0 is there. So only one row operation, that is R1 tends to R1 minus R2 is clear. This element minus this one. So the 3 0 1 plus 1 0 1 minus 1. That's all. second table, in table 2, A1 is same, but in place of A2, A2 is eliminated by X1. So we can write in place of A2, X1 and X2, S2. So objective function coefficients minus M, X1 coefficient is 5, S2 0. Next, after doing row operations, we are here 2, 4. First row, second and third row, no change. 2, 4. So here 5 minus 2. 5 minus 2 is nothing but 3, 0, 1. After doing row operations, so this is the matrix. Here no need to write A2. A2 is already eliminated. In second table, we cannot write A2. We cannot write basic variable is A2. Any part, we cannot write A2 on table 2 because A2 artificial variable is eliminated. So next, we can find delta J values. So delta J values, that is CB into Xj minus Cj. So this is formula. Delta J is equal to CB XP, CB Xj minus Cj. So this is the formula for delta J. So we can find out delta J for each and every CB into XP. 0, 5, 0. Total 5 and minus 5, 0. So next, CB into X2 minus M, 0, 0. Minus M, minus 6. So minus M, minus 6. So next, S1 multiply minus M, minus 5, 0. So minus M, minus 5. The next, all are zeros. 0, 0, 0, 0. And A2 also 0. All are zeros. Minus M, 0, 0, plus M. Minus M plus M, 0. So in this delta J values, so these are the two negative values. So we can substitute. This is minus 7. M is equals to 1. So minus 7, minus 6. In these two values, so which is the most negative value is nothing but minus 7 is most negative value. So we can choose entering vector as x2. Entering vector as x2 because this is the most negative value, minus m, minus 6. Entering vector are minus m, minus 6. So we can choose outgoing vector by using minimum ratio. So minimum ratio is, so this is xb divided by x2. So 3. First element 3 divided by 1, 3. Second element undefined. 2 by 0 is undefined. Fourth, third element is 4. In these three elements, 3 undefined, so minimum is 3. So that is outgoing vector is A1. So this is outgoing vector. X2 is incoming vector. The intersection of incoming and outgoing vector is, so this is key element. Key element. The next x2 is replaced by A1. X2 is replaced by A1. So that's why X2 can be converted into 1, 0, 0. Already 1 is there, 0 is there. So to convert this element as 0, to make third element as 0 by using row operations, so that is R3 tends to R3 minus R1. So we are getting here 0. This element as 0 because X2 is replaced by A1 in the matrix. So we can convert x2 as 1, 0, 0. Already 1 is there, 0 is there. So this element is to make this element as 0. So that's why R2 tends to R3 minus R1. So this is the row operation. And no need to write A A1 on next matrix. That is next simplex table. In table 3, no need to write A1. That is basic variables are A1 is replaced by X2, X2, X1, S2. Coefficients are 6, 5, 0. So 3, 2, 1. 0, 1, 0, 1, 0, 0, 1, 0, minus 1, 0, minus 1, 1. So next. So these are the, after doing row operations, so this is the matrix. So next we can find out delta J's. All delta J's. So delta J's are CB into X1. 0 plus 5, 0 plus 5 minus 5, 0. So next 6, 0, 0 minus 6 plus 6 minus 6, 0. Next here 6 minus 5, 1, 0, 0. The total 1. Next last one is 2. 0, 0, 0. Total 0. So therefore all delta J's are greater than or is equals to 0. All delta J's are greater than or is equals to 0. 0. Therefore the above table is optimal solution. The above table is optimal. So therefore the optimal solution is x1 value is 2. That is xb. x1 is equals to 2. x2 is equals to 3. x1 2, x2 3. So this is the solution of given simplex table. So therefore maximum of z x1 is equals to 2, x2 is equals to 3 in objective function here 2 3. So total 28. 10 plus 18 28. So this is the solution in big M method 28. SAQs using big M method are చెప్పండమ్మా.
Sir, model paper questions explain చేస్తాను చెప్పండి.
మోడల్ పేపర్ క్వశ్చన్స్ ఎక్కడ ఉన్నాయమ్మా? మోడల్ పేపర్ క్వశ్చన్స్ నెక్స్ట్ క్లాస్ లో చేస్తాను, గుర్తు చేయండి అమ్మా. నెక్స్ట్ క్లాస్ లో
సరే సార్.
ఈ మోడల్ పేపర్ లో వచ్చిన క్వశ్చన్ అమ్మా. ఇప్పుడు ప్రీవియస్ చెప్పింది 2x1 కావాలంటే చూడండి ఒకసారి. ఈ క్వశ్చన్ వచ్చింది 5x1 plus 6x2 x1 plus x2 is equals to 5 x1 greater than or equals to. ఈ క్వశ్చన్ ఆల్రెడీ వచ్చింది, కావాలంటే మీరు వెరిఫై చేసుకోండి. జనవరి 2021 లో ఎంత వచ్చిందమ్మా? జనవరిలో వచ్చింది క్వశ్చన్. ఇది ప్రీవియస్ క్వశ్చన్ కూడా వచ్చింది అనుకుంటా. ఇది కూడా వచ్చింది జనవరి 22 లో వచ్చింది క్వశ్చన్. ఈ 2 క్వశ్చన్స్ మోడల్ పేపర్ క్వశ్చన్స్ అమ్మా. ఇది జనవరి 22 లో వచ్చింది. ఇది నెక్స్ట్ 2-phase simplex method. So this is very important method. 2-phase simplex method. Two-phase simplex method. So this is also very important method. ఈ క్వశ్చన్ మీకు ప్రీవియస్ ఇయర్ ఎవ్రీ ఇయర్ లో వస్తుంది క్వశ్చన్. ఇది ప్రాసెస్ అడుగుతారు, థియరిటికల్ పార్ట్ అడుగుతారు. ఇందులో phase 1 నుండి అప్ టు ఇక్కడ వరకు, ఇక్కడ నుండి ఇక్కడ వరకు phase 1 phase 2. In 2-phase simplex method, here also same artificial variables. In phase 1, so this is phase 1. In phase 1, eliminating artificial variables, that is a1 comma a2. In phase 1, eliminating artificial variables. Next, in phase 2, in phase 2, we are getting optimal solution. So simple, in phase 1, eliminating artificial variables, and next phase, we are getting solution. Solve the following LPP by two-phase simplex method. So minimization, minimum of z is equals to x1 plus x2. So we can convert minimization to maximization. Maximum of z is equals to minus x1 minus x2. So that is multiplied by both sides minus x1 minus x2. Maximum of z is equals to minus x1 minus x2. Here also same. Here also same. We can add artificial variables. So two equations are given. First equation 2x1 plus x2 greater than or is equals to 4. x1 plus 7x2 is greater than or is equals to 7. So here we can add two artificial variables. So that is first one to make greater than or is equals to 2 equality. We can add some variables. First one to make greater than or is equals to 2 equality. So that is standard form. Next we can add artificial variables to equality case. So that is the first one here adding the minus s1 plus a2. Here minus s2. The standard form maximum of z is equals to minus x1 minus x2. And first equation 2x1 plus x2 minus s1. So we can add minus s1 to first equation to convert greater than or is equals to 2 equality. And one artificial variable plus a1 is equals to 4. Next x1 plus 7x2 minus s2. Second variable plus a2 is equals to 7. So these are the two equations. Here x1, x2, s1, s2, a1, a2 all are variables greater than or is equals to 0. Next, phase 1. In phase 1, we have to eliminate artificial variables in phase 1. So that is eliminating a1, a2 artificial variables. In next phase, we are getting optimal solution. In phase 1 simplex table. So here also same. In matrix form. First equation coefficients, second equation coefficients is equals to 4, 7. Next, basic variables. So basic variables are always artificial variables, a1, a2, basic variables. In objective function, in big game method, we can add minus m2 coefficients. So, but in simplex or in two-phase simplex method, we can add minus 1. Coefficient is minus 1 in objective function. So that is all objective functions are coefficients are 0, 0, 0. And only we are taking minus 1 to artificial variables. Remaining all are zeros. In CJ, in table 1, phase 1, CJ values all are zeros. Expect artificial variable. We can add artificial variable coefficients is minus 1, minus 1. Here also minus 1, minus 1. XB is equals to 4, 7. Next, same matrix here. 2, 1, minus 1, 0, 1. So this is the second row. Next, we have to find out delta J's. CB into XB. Minus 2, minus 1. So that is minus 3, minus 0. So total minus 3. Next, second one. So minus 1, minus 7, minus 8. Next, third one. So remaining plus 1, here plus 1, here minus 1. All are delta J's. So first delta J in these negative values, all these delta J values, the most negative value is minus 8. So this is the incoming vector. So most negative value is -8. So this is incoming vector. So next we can choose outgoing vector by using minimum ratio. So minimum ratio is nothing but xp by xj, xp by x2, 4 by 1. First one 4, 7 by 7, 1. So that is minimum element is 1. So outgoing vector is a2. Second artificial variable a2. Is clear? So this is the outgoing vector. So next, so a2 is replaced by x1. So we can convert x2 as 1. Yes, 7 is there. So total row multiple divided by 7. R2 divided by 7. 1 minus 1, 0. Next row. So next row, x2. Here we can write x2. Printing mistake. Here x2. x2, a1, x2. x2 coefficient in Cj 0. Here -1, 3, 1. So this after doing row operations, we are getting this matrix. So this is the matrix. So here printing mistake. Here x2, x2 is clear. Next, we can find delta J values, all delta J values. So these are the delta J values. So by using previous formula, in these delta J values, the most negative value is -13 by 7. The -13 by 7 is the most negative value. So x1 is incoming vector. Next to a2 is outgoing vector. a1 is outgoing vector. So intersection of incoming and outgoing vector is key element. So this is multiplied by 7 by 13 because x1 is converted to a1. So that is x1 as 1, 0. So that's why we are making 1 multiplied by 7 by 13. So these are the incoming vector x1, outgoing vector is a1. x1, x2, 0, 0. So this is the matrix. So all artificial variables are eliminated. All artificial variables are eliminated. So next we can go to phase 2. In phase 2, in phase 2 here in Cj, only changes in Cj. In Cj we can allocate original coefficient values. x1 coefficient value -1, x2 coefficient value -1 on here. Remaining all are same. And no need to write artificial variables. So these are up to here only. Table up to here only. And here we can add -1, -1 in phase 2. Phase 1 is nothing but basic variables are replaced by artificial variables are replaced by variables like x1, x2, maybe s1, s2, any variable. But we have to eliminate artificial variables in phase 1. After eliminating artificial variables in phase 1, all the delta j's are greater than or equals to 0. Next, x1, x2, CB, -1, -1 coefficients. Say in this matrix, -20, 21 by 13, 10 by 13, 1, 0, -7 by 13, 1 by 13. So this matrix as this. Next, we can find delta J values. All delta J values are greater than or is equal to 0, then the table is optimal. In case any delta J is negative, any delta J is negative, so that is incoming vector, we can choose outgoing vector. Is clear? All delta J's are greater than or is equal to 0 in phase 2, so therefore the table is optimum. So therefore, the optimal solution is x1 is equals to 21 by 13, x2 is equals to 10 by 13. So this is the solution. So answer 31 by 13. Maximum of z is equals to 31 by 13. So this is the solution in two-phase method. In phase one, so we can eliminate artificial variables. So this is phase one, and all delta j's are greater than or is equals to 0. Next, we can proceed phase two. We can add coefficients, original coefficients, that is minus 1, minus 1. In phase one, all coefficients expect artificial variable coefficients are minus 1, minus 1. Remaining all coefficients are zeros. So 0, 0, 0, minus 1, minus 1. So this is the two-phase simplex method. So next example 2 is there, example 4. Example 4 also same.
Sir, one doubt,
చెప్పండి,
sir.
వాయిస్
సార్ ఇక్కడ
రావట్లేదు.
టేబుల్ వన్ లో ఈ A1 A2 యొక్క డెల్టా జే వాల్యూస్ జీరోస్ అవుతాయి కదా సార్, -1 ఉన్నాయి
ఇక్కడ టేబుల్ 1 లో ఎక్కడ చెప్పండి,
48 లో
టేబుల్ 1 లో ఇక్కడ. ఓకే,
లాస్ట్ లో కింద సార్ డెల్టా జే వాల్యూస్ ఆఫ్ A1 A2
A1 A2 ఒక్క నిమిషం అండి. A1 A2
కింద సార్ -1 ఉంది.
-4 0 -4 0
సిబి ఇంటూ 1 కదా సార్,
PB into XP, PB into XP. సో
-1
-1 -1 + 1 0 వస్తుంది. ఇక్కడ రెండు జీరో వస్తాయి, ప్రింటింగ్ మిస్టేక్ ఉన్నట్టున్నది. జీరో చాలా వరకు ఉన్నాయి మిస్టేక్స్. జీరో అక్కడ
అది రెండు
+1
జీరోలు
-1 +1 -1 A1 రెండు జీరోలు వస్తాయి. ఇక్కడ A1 0 వస్తుంది, A2 0, టూ జీరోస్ వస్తాయి. ఓన్లీ
అవును
మనకి x1 x2 మాత్రమే నెగిటివ్ వస్తాయి. ఈ x1 x2 లో ఏదో ఒకటి చూస్ చేసుకోవాల్సి వస్తుంది. ఈ రెండు జీరోస్ ప్రింటింగ్ మిస్టేక్. ఇక్కడ మిస్టేక్ ఉంది. ఇక్కడ నెక్స్ట్ కేస్ లో కూడా ఇక్కడ మిస్టేక్ ఉంది. ఇక్కడ
అది
x2 రాయాలి,
అవును సార్.
x2 రాసుకోవాలి. ఇక్కడ A1 ప్లస్ A2 ప్లస్ లో x2 ఉంటుంది. ఇది కూడా మిస్టేక్ ఉంది.
ఓకే సార్.
So this is the simplex table. So here second example is there, example 4. So one is less than, one is greater than is there. So less than case we can add on one artificial one variable s1. So this is s1. Next, in greater than or is equals to case, so we can add minus s2 plus a1 also. ఇక్కడ a1 ఆర్టిఫిషియల్ వేరియబుల్ యాడ్ చేస్తారమ్మా. ఇక్కడ ఇవ్వలేనట్టున్నారు, కానీ యాడ్ చేస్తారు. ఇక్కడ కూడా మిస్టేక్ ఉంది. a1 యాడ్ చేయాలి. We can add a1. Example 4, in standard form 3x1 plus 4x2 minus s2 plus a1 is equals to 12. ఇక్కడ a1 యాడ్ చేయాలి. అదే a1 ఇక్కడ టేబుల్లో ఉంటుంది, చూడండి ఒకసారి. టేబుల్లో ఉంది, a1 ఇచ్చాడు బేసిక్ వేరియబుల్స్. ఇక్కడ కూడా మిస్టేక్ ఉంది, రాసుకోండి. ఇక్కడ a1 యాడ్ చేయాలి ప్లస్ a1 సెకండ్ ఈక్వేషన్ కి ప్లస్ a1. ప్లస్ a1 యాడ్ చేసి సో ప్రీవియస్ మెథడ్ ఫాలో అయిపోతుంది మనకి సొల్యూషన్. సో మీకు ఇది 4 మార్క్స్ కి లాంగ్ క్వశ్చన్ అడుగుతారు. సో దిస్ ఇస్ ద యూనిట్ 3, బిగ్ గేమ్ మెథడ్ అండ్ సింప్లెక్స్ మెథడ్. So next class we will discuss previous model paper question sign important topics in next class, next Saturday.
ఓకే సార్.
సార్
చెప్పండి. హలో
సార్, యూనిట్ 9 ఇప్పుడు ఒక ప్రాబ్లం ఎక్స్ప్లెయిన్ చేస్తారా సార్?
యూనిట్ 9 ఏంటమ్మా? యూనిట్ 9 లో
జాబ్ సీక్వెన్సింగ్ ప్రాబ్లం.
జాబ్ సీక్వెన్స్ ప్రాబ్లమ్స్ ఒకసారి నాకు మెసేజ్ చేయండి అమ్మా, నేను చూసి చెప్తాను. నేను నెక్స్ట్ క్లాస్ లో డీల్ చేస్తాను. అది జాబ్ సీక్వెన్స్ ఆల్రెడీ చెప్పాను అనుకుంటున్నాను. యూనిట్ 9 ఒక్క నిమిషం ఆగండి. ఓవర్ యూనిట్ 9 చెప్పలేదమ్మా, నేను చెప్పినట్టున్నాను అది. నాకు చెప్పండి అమ్మా, నెక్స్ట్ క్లాస్ లో నేను డీల్ చేస్తాను. యూనిట్ 9 చెప్తాను నెక్స్ట్ క్లాస్ లో. అది మీకు ఏమైనా డౌట్స్ ఉన్నది నాకు మెసేజ్ చేయండి. నేను నెక్స్ట్ క్లాస్ లో మీకు యూనిట్ 9 ఇంకేమైనా ఉంటే ప్రీవియస్ ఇయర్స్ క్వశ్చన్ పేపర్స్ అవన్నీ డీల్ చేస్తాను. నెక్స్ట్ క్లాస్ లో చూద్దాము. ఓకేనా, విల్ కంటిన్యూ నెక్స్ట్ క్లాస్.